Hi everyone, welcome to Think You Know SunLink Roof Mount Systems Think Again webinar. My name is Yuri Reznikov. We're going to be talking today about the SunLink new roof mount system. Thanks for joining. This is a system that you can see in the picture in front of you. We announced this system a couple months ago, and what we wanted to do today would really talk about some of the differences in terms of philosophy, methodology, installation. We think this is a pretty unique way to approach mounting systems in general, and we wanted to talk to you about that. So my name is Yuri. I run products here at SunLink. I've been at SunLink for a little bit more than 5 years, and I'm responsible for the product roadmap, how we go to market with our products, what our products look like, development, etc. We'll go into some history on SunLink and really how we came to this point. We do have a dual product strategy with respect to our roof mount products, so we'll discuss that. And then we'll dive right into the system. We'll talk about the design piece, the logistics, installation, and then the removal and reinstallation. And this has been a concern for some of our customers who are actually owning the system in terms of what do you do after 10 years, after 15 years, when you want to do some maintenance, when you want to reinstall your roof or replace your roof, what does that mean for the system? What does it mean for the components? And then we'll talk a little bit about some of the online resources we have, live demos, training, and we'll obviously be at SPI with a pretty big showing as well. We're going to be taking questions throughout the presentation, depending on, if there's appropriate questions at appropriate times. Please use the Q&A section in WebEx to ask questions. We will either respond to them as we move forward through the presentation, or if we don't get a chance to answer all the questions at the end, we will definitely respond to everything either by email or through some other way after the call. So SunLink has done about 500 megawatts, more than 2,000 different sites. You can see a map in front of you of where we've done projects, and it's quite a few places. And so we're very familiar with various AHJs, permitting requirements for different states. We're familiar with different environmental conditions, snow, wind, exposure, roof height, etc. And we're familiar with obviously different roof types. So weak decks, different roof types, etc. So a lot of different experience throughout our history, a lot of different types of projects. And so through this experience is really where we kind of came up with our product roadmap. And so going all the way back to 2004, the company was founded on the SunLink RMS system. We've had that system for almost 7 years, and it was the first fully ballasted system out on the market, which was a significant differentiator at the time. Since then, we've evolved that system to the Precision RMS product. So this product is, we're not going to talk about it today, but it's a product specifically designed for more challenging conditions, for weak roof decks. We take much more care in terms of point loads with this system on how to align those point loads over the structure. What does it mean when we have 150 mile an hour winds? How do we design a system that's rigid, that can withstand those, while at the same time minimizing ballast and minimizing connectors? Having said that, on the other side of the arrow, you can see kind of the other system, which is the core system, which we are still have in play today. We're still supporting that system. And this is the system that we said, well, not all projects are going to be at 150 mile an hour wind zone. Not all projects are going to have weak roof decks, etc. There needs to be some more of a standard system where we can get to a lower cost point, that we can have quicker installation, less components, etc. And that's really why we have a dual product strategy between the kind of high technical requirements and more the everyday system. And we think that probably that split is somewhere 30% to 70%, with the 70% really is the kind of the everyday system. And so again, what we're talking about today is the Precision-Modular product. It's a new product. We released it a couple months ago, and this is again for those types of kind of general conditions. This is not the product for the big high snow loads in the coast of Florida, but it is the product that is much more cost effective than some of our legacy products. It's much easier to install. It has a significantly different methodology from a design side, logistics side, installation side, and we think this is going to be a very successful product for us, really replacing the core system either by the end of 2014 or sometime in 2015. The other piece that I wanted to talk about is this is really what we hear from our customers, and I don't think there should be any surprise to the kind of those folks on the line that have been in the solar industry for a little time. I think these are all fairly obvious, but just to give you an idea of what we thought about or what were we trying to address when we thought, okay, if we take a blank sheet of paper, what would a mounting system look like? What needs does it have to solve? And, you know, just to quickly go down this list, is lower cost, given where the industry is, I don't think that's any surprise. We want fast design cycles, so we should be able to turn around design and engineering and permitting packages very, very quickly to give customers an idea of what the system's going to look like, what it's going to cost, what are the requirements. We want quick installation. When we look at total installed costs, it's not just the system cost, it's also the installation cost and labor times. We want short lead times. How do we shorten? We don't want systems getting on site 8 to 10 weeks. We need that to be 2 weeks, 3 weeks, etc. We need the flexibility as we're trying, or as the industry is trying to fit more on rooftops, given the price point. Density is important. We have to be able to go around various obstructions, air conditioning units, etc. Wire management, which by some accounts takes up 30% of labor. That's a significant portion. How do we integrate that? How do we make it easier for our customers? And the last one is really what I mentioned before is, yeah, you can install the system, but especially for the owners that are going to be owning this system for a long time, what does it mean when they have to replace the roof? What does it mean when they have to do maintenance or do certain things after the system's in place? How do we minimize some of those pain points as well? So this is really what we thought about, and I think we succeeded. I'll go through a lot of these in the presentation. This is the system. So it's a modular system. We designed it module by module. It comes at a 10-degree tilt, rubber feet in terms of interfacing with the roof. We've been fairly successful, depending on the roof manufacturer, of not providing slip sheets, so we can just put the rubber feet on there directly with the rooftop. We feel comfortable with that in terms of thermal expansion, contraction, and kind of having the roof surface not be damaged. We have standardized components for 60 and 72 cell modules. We'll support 99% of all those, and we'll support some other modules as well, some of the 80 cell or some of the 96 cells, some of the more unique modules out there on the market. It's an all aluminum system, except for the deflector, so it's well positioned to be in places like Hawaii or other coastal regions. And of course, we have the integrated grounding. We're at 2703. The system is connected north, south, and east-west through metal members. So as far as grounding, it is one point on an interconnected array, and that's it. And then, of course, as I mentioned, there is some interesting integrated grounding as far as trays and clips that we also have that I'll get into later to kind of minimize some of the wire management issues. This is why the system is called Precision-Modular. This is a little bit different than what we've done in the past. And what we wanted to, as I mentioned previously, we wanted to maximize the density and maximize the flexibility of the system. So we wanted to design this system as one module at a time. So what I'm showing here is just basically an example of a layout. And there's not too many obstructions there. This is so not too broken up, but you can see certain spots where we have to take one module out and leave the others in, or we have a peninsula with only 2 modules sticking up there. That's important. If we're going to be maximizing the density of the system, going around obstructions, we wanted to make sure that we're using every nook and cranny of the roof, because we do have customers asking, hey, you were able to fit 500 kW, can we get to 550? Can we get to 575? What's the maximum that we can put on this roof, given where the cost of the system is? And that's absolutely important. The other piece in terms of density and layout, this is a very high density system. So a lot of that is on purpose through the design. You can see the angle of the deflector is a fairly sharp angle. It's very, very close, and we did that on purpose to have the modules fairly close together while still giving the proper shading requirements. And so we typically design for plus or minus 2 hours on December 21st for shading purposes. And we're able to achieve that with a very small D over H. So 1.7 is really the minimum, or if you think in terms of ground cover ratio, that's a 78% ground cover ratio, while still keeping shading requirements in check and still keeping the aisleways fairly open with enough room for folks to walk through, do the installation, do the maintenance, etc. So what happens when we have different latitudes? Because if we're looking at shading requirements in, let's say, Los Angeles are very different than shading requirements up in kind of the northern latitude, let's say Boston. We've built in some adjustability into the system, and that's why kind of in the top bullet we say, look, it's a ratio of 1.7 to 2.6, 68% to 78%. And that's because when you're doing a project at higher latitudes, you want to space those modules out a little bit. And so that the rail link is what allows for that adjustability. There's a hole in there, you put the bolt through the hole that you want to standardize the spacing on, and you're pretty much done. So there's a lot of adjustability, a lot of flexibility in the system just from that point of view. The other piece is on the design side of the engineering. So we've got the system laid out, we've filled every nook and cranny, we've got the density requirements, we've got the shading requirements. Well, now we need to figure out what the system is going to look like from an engineering perspective. Do we need a ton of ballast? Do we need a couple, outriggers? What is this thing going to look like permitting package-wise? And so what we've done with the system, which again is a little bit different than what we've done in the past, is we've done a lot of testing in terms of wind tunnel testing. We've probably done 6 or 7 different series of tests throughout the years, each time learning more and more. We've tested different roof heights, different tilts, different directions of wind, different row spacing, all kinds of different parameters, and we've got terabytes and terabytes of data. So we take that data, we combine it with some of the seismic data, and you can see on the right-hand side, the lower picture is actually a full-size shade table to be able, we've done the testing there to be able to understand what are the seismic requirements for our system in a purely kind of fully ballasted mode. So we've combined the wind data, we've combined the seismic data, and what we've done is we've developed tools to be able to go right from layout to engineering in a fully automated way. So what we're trying to do is not create 2 processes where, well, here's your layout, and then now we need to go to engineering. The goal is really to have layout and engineering be one. Once you've done the layout, you feel happy with the layout, engineering is basically automatic. And what you get out of that engineering is a map. You can see it in the picture below, which has your ballast requirements. So that's very, very simple, very, very quick, very automated, and that's having to do for us to be able to take that data, translate it into tools, and then develop software pieces with that. So you've designed the system. Now let's talk about logistics. This is another thing that went into this product, and it was very important for us to basically standardize components. And so what we've been able to do is we've been able to standardize the components for 60 and 72 cell modules. There's only a couple of differences between those 2 modules, and frankly, most of the customers we see standardizing on 72 modules these days. So really, that's the goal. The goal there is keep inventory, have parts in order, so that when we're talking about lead times, now we can turn something around, within 2 weeks, 2 to 3 weeks, versus going out there talking to our suppliers, designing for a particular module or for a particular project. Now that's much more simplified. And when we actually ship the product out, we've developed some very, very high-density packaging, high-density components, specifically to basically minimize shipping costs, to minimize on-site transportation costs. If you have to crank things up to the roof, you're craning only a couple of boxes versus a whole lot of pallets. You can see some pictures there below of how dense the system actually ships. If you're familiar with LTL shipping or FedEx, it is a class 50 or 60, which defines really the density of air to material mixture for those companies. The other piece that I wanted to mention on the logistics side is that we only have 2 shipping locations for this product because it's so simple, because it's, we can keep inventory. We're really minimizing how many places this comes through. We have high level of quality controls at those 2 locations. And not only that, do we have developed basically a shipping portal, and this is not necessarily specific to this product, but our customers want to know when has it been shipped out, where is it, when is it expected to arrive, has it been delivered, etc. So with our partners and our shipping partners, we've been able to put a portal in place. You can log in, you can see where the shipment is, what exactly is the status of that shipment, and then when it arrives on site, you can see the picture to the right is basically kind of a bill. You have the sales order there. You can look it up. You can understand what goes into that box, what's on that pallet. You can look it up. Everything kind of is automated through that portal. So it gives a lot of transparency. So once you've designed the project, and now that it's been shipped out, you know exactly where it is, when it's expected to deliver. You don't need to communicate by email or call folks. And then once it's there on site, you can easily check what's there, what are the parts, what did I get, what didn't I get, what's yet to be delivered, etc. So let's talk a little bit about installation. You've got the project design, it's now on site, and this is where there's some very, very unique things from that. And what I wanted to do first is I wanted to show an animation, and I'm hoping this comes through the WebEx, and if not, you can find that on our website. But I want to let everybody watch the animation. It's very quick, and then I'll go through some of the highlights from that animation, and let's see if it works. There it goes. Great. So I hope that worked okay for everybody so they could see what the system installs like. And some of the components, when you're doing the quick animation through WebEx, it may not be as clear as we'd like. So what I wanted to do is I wanted to take you through just a couple of highlights and point out a couple of the unique things when we designed this from an installation perspective. So the first piece that I wanted to talk about is this jig. And so this is something that I think we're pretty much the only ones in the industry doing this. But what we wanted to do is we wanted to eliminate any sort of alignment. We wanted to eliminate any sort of measurement, anything on the rooftop. We see a lot of folks, basically, you're trying to put the module on, you're kicking things into place while you're holding a heavy module, you're trying to align bolt holes, etc. And it may only be a couple of millimeters, but it takes up so much time and so much effort to get those spacing exactly proper and the alignment, and to make sure that the array doesn't walk on the roof and is crooked. We said, look, let's eliminate all that. And this is what we came up with. So it's a jig, and it uses one of the modules on the project. We've designed projects in the past that we designed from a spec sheet, and then we get onto the site and the module's been modified or is a little bit different. Or at the last minute, the customer decides to switch the module out. So we said, okay, well, let's build the jig off a project module. That way, it's foolproof. The spacing is there, the alignment is there, everything is there. We put 6 components as a one-time thing onto this module, and that's actually what's used to align and place the components. The next step is to actually place those components, and it may be a little bit hard to tell, but you're placing the rail, some of the ballast beams, the north strut, the rail link. All these components basically very quickly go onto the jig, and they're secured by only 2 fasteners. So if you look at that lower picture on the right-hand side, what we have here is the rail link, the rail, the north strut, and the ballast beam, which is 4 components, but as you just put them down, they go exactly where they're supposed to go because the jig aligns them, squares them, and you attach them through one fastener. All those components kind of stay in place, are square and perfect. And then when you go out, now you've built this substructure, you take it off the jig, you put it onto the roof. Again, no fasteners required on the roof. The next substructure slides into the previous one. It connects there. The fastener is already there. It's already in place, and it basically automatically measures the distance between those 2 substructures. When you put the module on, again, no fasteners required on this step as well. The system's already perfectly aligned for that module. You slip the module onto the south side for that fastener that's already there. The module clamp already basically aligns the module onto the rail. You slide it down, and on the north side, a hook basically holds onto the frame. You tighten down the fastener on the south side, and you're pretty much done with the module placement. And before this step, typically you would want to put the ballast down ahead of this when just the substructure is on, as you saw in the animation video. The next step is you put the deflector on and the side link. The deflector just snaps on. It goes onto the existing bolt that sticks out. So you basically, to complete the entire installation, the only thing that you're carrying onto the roof with you besides the components is 2 nuts per module. 2 nuts per module to hold down the deflector. So the system was designed to really minimize the number of fasteners. Each fastener typically secures 2 or 3 different components. So the components go in place, are already auto-aligned, auto-secured, auto-measured, and then very few fasteners kind of secure multiple components in place to make that very, very simple and easy. The other piece that I want to talk about is wire management. So typically we see some customers actually do the wire management before the module goes on, after the ballast, so that they can do some of the string wiring, maybe the home run wiring, put harnesses out in place, secure those. The system is wide open, it's very easy to work with. Or you can do it after the module, then you can secure the module leads, leave the deflector off. You have a lot of room underneath the module to make sure you're running your wires appropriately. And then obviously the third option is you do it after the deflector and you're running your string wires or home run wires on the outside. And we have a couple of different solutions for east-west and north-south. One of which being as you can see on top there, is the SunLink wire U-guide. This goes onto the outside of the deflector, allows you to basically run bundles of wire through that east-west. If you prefer to run wires, we see most customers underneath the module, away from the sun. We have special clips. They clip onto the north strut. They're non-chafing clips that you can either put 3 wires right through them, or they have an opportunity to put a wire tie on top or below and put a bundle of wire east-west, or potentially even run conduit there east-west if you have the preference. So very easy to run east-west. North-south is where we see a lot of customers struggle, primarily to put wire between rows. Without the wire basically hanging off the side or zip ties or what have you. So we have a couple of different solutions. Again, the deflector opens up. There's little tabs on the deflector that allows you to run a bundle of wire north-south. And you can use a U-guide to secure that bundle of wire with a zip tie or some other clamp. But that allows you to run wire north-south. And the other piece that we've developed is a SunLink wire tray, which goes from the south of one module to the south point of another module. It carries about 10 wires, and it's a very easy way to basically put those down and run bundles of string wire back to the combiner box, or even, depending on what you have there, home run, harness, etc. So those are kind of a couple of the different solutions that we have for wire management. In my experience, everybody does it a little bit differently, so these are not the only ways to do it, but we think this is what makes sense in terms of east-west and north-south wire management. So I mentioned this a couple of times as far as the removal and installation, and I wanted to point out that when we're installing the system, it's not the same as uninstalling it and reinstalling it. I mean, we're talking about very different processes to do that procedure. And this absolutely makes sense when you're looking at a system out there, as I mentioned, for 30 years or so, and you need to replace the roof in 15 years. What does that mean? Well, it means the substructure comes as one piece, the module comes as another. You have a deflector and a side link, so you only really have 4 components. All the fasteners are already attached, the system's pre-aligned and kind of measured for that module. And so the only thing you're removing from the system is 2 nuts. And so with 2 nuts, you're able to take the system apart, stack it in place. You're probably, on assembly, you're probably saving 50 to 60% of that initial installation time removing the system, so you're not doing double the work. And then when you're putting the system back, you're not using a jig, you're not assembling all of these components. They're all stacked in place. You're putting the pieces right back, and it's about 30% of the initial labor calculation. So if you're looking at a lifetime of the project and you want to own this for the next 20, 30, 40 years or what have you, you really need to take into account, well, what is it going to cost me to do certain maintenance activities from the rooftop? And removing the mounting system or removing the system as a whole and putting it back in place is a considerable cost. We've tried to optimize that. We've tried to make that easy for our customers. So this is basically it. I mean, this is the system. This is what we've designed, and this is a little bit summary. It's the same slide that we put on the beginning as far as customer pain points. And I wanted to make sure that we went through and addressed each one of these, and I hope we did that for the folks online. But we absolutely wanted to get a much lower cost product. We wanted to optimize the design cycle, improve the installation, not just in terms of speed and number of components, etc., but really in terms of kind of alignment, measurement, make it easier for these guys or folks to work on the rooftop. Lead times, flexibility, again, from a design perspective, wire management, lowering the labor rates there, and then the overall ownership costs and the maintenance costs throughout the lifetime of the system. That's what we focused on, and I think we've addressed them in a very good way. We'll obviously be at SPI. I mentioned that. Please, if you're there, come visit us. Booth 318. We'll obviously have the modular system as well as some of our other products online. You can feel, touch, ask us any questions. We'll be there in full force. We have a very nice presence at SPI. And if you happen to be in California, we also have a warehouse and a training facility. We take a lot of the customers there. You can do time trials. You can play around with the system. You can understand how it goes together. And we can walk you through that. We have a team that's responsible for managing that. So please reach out to us. All right, so I didn't get a chance. I went right through it, and I didn't I didn't get a chance to answer any questions, although they were coming in. So let me take a couple of these right now. If anybody has any additional questions, feel free to put them under Q&A. We'll try to get to at least a couple of them right now, and then we'll leave the rest to answer offline. So, can modular be fully connected or a hybrid system? That's a good question, and I should have mentioned that, but absolutely. So we do have a connector. We typically see, or I should say our preference is to design fully ballasted systems in high seismic zones. I talked a little bit about that. We do expect to have some connectors. A lot of the AHJs or permitting officials will not accept a fully ballasted system. So we have a methodology and a process to put a couple of strategically placed connectors to help with some of the seismic. And then the other way that we put connectors is for where we have a lot of ballast. So particularly in kind of the north corners, we see a lot of the high loads there. Instead of putting lots of different pavers there, we can put one connector and minimize some of the paver requirements or some additional components of the system. And that's what our methodology is, or that's kind of what we expect to do from a hybrid system perspective. On a fully connected basis, the system could support it, but it would mean lots of connectors, and it's probably not going to be economically feasible. And that's exactly, or I should say that's one of the reasons why we have a dual product strategy, is that's the perfect fit for a precision system. It's a much more rigid system. It does a much better job of transferring the load from one connector to the next. Okay, so we have a question on modular price and a question on lead time, and I'll take both of those. From a pricing perspective, I think it's the kind of the answer in the industry, it depends. It depends on the layout, it depends on the particular project, it depends on the volume and the size of that particular project. But suffice it to say that this product, much more economical than our other ones. We are well under 20 cents, significantly under 20 cents for, I want to say, all different projects, all different modules. And then obviously it depends on that particular project. And then from a lead time perspective, again, this is where we've done a lot of work, and I should have mentioned that we are building up our inventory as we speak. And so after that initial round of inventory, it really should be no more than 3 weeks. We should be able to fulfill most projects within a matter of 2 weeks. Another question, what module manufacturers is this system approved with? So 99% of the systems it would work with. We've gone out to actually seek approvals with the top 5 module manufacturers, and have not had a issue or concern. So everybody's looked at this, and I should be clear that we're using a very innovative or unique hook on the back end so that we can mount the module without using any sort of fasteners on the north side. We have approvals from those module manufacturers. We don't see an issue with anybody else as well. The only concern there is if we have a weird shaped module, does the system accommodate that, not from a mounting perspective, but just from the size of the components perspective. But we don't see that as an issue. Another question, what rooftop types can you not accommodate? So we accommodate all flat roofs. Slope roofs we do not accommodate, so anything that's a slope roof, standing seam roofs, anything like that, this product is not designed for. But your standard TPO, EPDM, PVC, built-up roofs, those work fine. Obviously, it depends on the roofing manufacturer, whether we need to use slip sheets or not use slip sheets. Okay, here's another question regarding module clips and how we deal with that in terms of shipping and trays, etc. So From the wire management perspective, we're very flexible. We don't include that into the BOM. That's on a customer by customer kind of way. We offer the system, we offer the wire management solutions to our customers. Other customers may prefer a different solution, which is fine. We want to simplify that, and we want to make it easy. Typically, the processes will work with the customer to understand what their wiring plan is, how they accommodate the wire leads, how are they running string wires, are they using string inverters or central inverters, combiner boxes, etc. And then based on that kind of single line diagram, we can say, well, you probably want kind of trays in these locations, you probably want clips in these locations. So we work closely with folks on the system with respect to wire management, and then depending on those requirements, we support them with either third-party products that they can go order themselves, or we'll support them with our wire management solution. Well, here's a detailed question in terms of types of ballast that we support, and this is important because the system is really designed to support any size of ballast. What we typically see is a 12 by 12 ballast block, but the rails or the ballast beams that hold the ballast are fully adjustable. So we can set them to 12 inches, we can set them to 16 inches as well. So if it's easier to get 16-inch, 16 by 8 ballast blocks, that's fine. We just need to be able to accommodate that and know that ahead of time. And we can support that as well and do all the engineering based on the weight. So whether it's 24 pounds, 26 pounds, 32 pounds, we can support any of that. How does portrait versus landscape affect the 10-degree tilt? So the system is designed in landscape. You know, the core system, which is the legacy system, is designed in portrait. And there's not a lot of differences there. There's some differences on energy production. Depending on how shading is and how the modules are actually wired, you are able to squeeze in a little bit more energy production when in landscape. The system is also lower to the ground when in landscape, but it does take up a lot more room per module east to west. North to south, it's a lot less. And given our density studies, from that perspective, we don't see a big difference. In some methodologies or some system architectures, if you're using clips, top clamps, you're able to share clamps, so portrait may be more cost-effective system. And here, let's just take one more. Do we provide services for framing or evaluation of decks, etc.? And we do not. So we will work with the SCOR, so the structural engineer of record, on the client side. We will work very closely to make sure that our system and all the loads meet those requirements. But we will not obviously take responsibility for that. We will not go out to the site and do an analysis. We have very good partners that we can recommend. So if a client is looking for somebody to help on the structural side, we obviously know a lot about that and can do that and help folks out. So there's quite a few other questions. I want to make sure that we get to them, so we'll get to them all offline, and we'll respond to them by email. I'm sure if you register, we have all that information. But I wanted to make sure that folks, if you want more information, please go to SunLink/Modular. We also have a YouTube channel. You can get it off of our website, or you can go directly there. What we've done is we've actually videotaped a step-by-step installation process. We broke that down 6 various steps, so everybody can get familiar with what exactly does this look like from an installation perspective, besides the animation. And then if you want just more information in general, feel free to contact us at sales@sunlink.com. Call the number below. My email is not on here, but feel free to reach out to me. It's yury@sunlink.com, so just my first name. If you have any other questions on the webinar itself, please shoot us an email at webinar@sunlink.com. Thank you for your time.